Today I am going to see errors in measurement. See what is measurement, what is errors and types of errors, and then finally can see limitation of types of errors. See what is the error. You know that the difference between the actual value of the quantity and value obtained by the measurement is called error. It's a definition, but very simple. You see that actual value minus measured value, that's all. Suppose if actual value is 17.8, measured value is 17.6, so what's the error? 0.2. So this is the way we can see the errors. See the types of errors. There's a three type of errors are there. One is systematic error, second one is gross error, third one is random error. But in the case of systematic error, this is due to flaws in experimental system. That means the systematic error involves observer, measuring instrument and environment. So this type of error can be eliminated only by detecting the source of error. Okay, further we can classify the systematic error into three types. One is personal error, instrumental error, environmental error. See, let us see what is personal error. Personal error is already familiar, that is a parallax error. These errors are arise due to faulty calibration or faulty procedures adopted by the person making measurement. See the diagram, the original value is 4.8. Suppose if you are standing at the left side, you can see your reading is 4.7. Suppose you are standing right side, your reading is 4.9. So these are called a parallax error. Next one, instrumental error. See, before you are taking reading, some error is there in the device, that is called instrumental error. So already familiar in vernier caliper and screw gauge, before you are taking reading, you should see the negative 0 error and positive 0 error. So these are called instrumental error. Next one, environmental error. These errors are caused by the external conditions like pressure, temperature, magnetic field, wind, etc. The following steps that must follow in order to eliminate the environmental error. How will you eliminate the environmental error? One is to maintain the temperature and humidity of the laboratory constant by making some arrangement. But second thing, ensure that there should not be any external magnetic or electric field around the instrument. Why? Because that will affect the experiment result. And advanced experimental setup, you can see the diagram. See gross error, it's also caused by mistakes in using instruments, recording data and calculating results. That means faulty if you are noted one but you are writing other reading, so this also leads to gross error. For example, a person may read a pressure gauge indicating 1.01 Pascal and he noted as 1.10 Pascal. This leads to error. By mistake, a person make use of an ordinary electronic scale having poor sensitivity to measure the very low masses. So careful reading and recording of the data can reduce the gross error to a greater extent. Finally, we can come to the random error. Random errors are due to unknown causes and are sometimes termed as chances error. Due to unknown error causes, they cannot be eliminated, but they can only be reduced and the error can be estimated by using some statistical operations like error analysis. See, if you take the period of simple pendulum with the stopwatch 5 times, first time you get what's at 3.9, second time 3.5, third time 3.6, fourth time 3.7, fifth time 3.5. From the result we can see what is the mean value. Why your teacher are asking you to take mean in physics or chemistry experiment or practicals? Why? Because the 5 or 6 times you are taking and then you take the arithmetic mean. This will also leads to reduce the error. We cannot eliminate, but we can reduce the error. See the formula. The mean is equal to 1 by n into summation of xi. So you can add all the numbers, all the value 3.9, 3.5, 3.6, 3.7, 3.5 divided by 5. So mean value is what's that? 3.6. And absolute error, what's absolute error? It's a difference between the mean value minus what's it, individual value. For example, 3.9 is the original what's it, value, 3.69 minus mean value 3.6. So what you're getting? 0.3. This is the absolute error. The same way you can take each and every reading, and finally you can come to what's it, mean absolute error. Arithmetic mean of all the absolute errors are called mean absolute error. So del x bar equal to 1 by n into del xi. You know that the error already calculated, and then take the mean for the errors. So you can get what's it, 0.1. This is a mean absolute error. And then report. How do you give report? Report must be in the form of best estimate plus or minus errors. For example, the period of simple pendulum is likely to be within 3.6 plus or minus 0.1 second. So this is the way you have to give report. Relative error is very simple. Relative error is defined as the ratio of the mean absolute error to the mean value. What's that? Ratio of the mean absolute error to the mean value. You know mean value 3.6. Already calculated the absolute error 0.1. So 0.1 by 3.6, 0.0277. That means 0.028. This is a relative error. And finally come to that percentage error. The relative error multiplied by 100 is called percentage error. Relative error already calculated already we have calculated 0.0228 into 100, that is 2.8%. So you can come to that how we are closer to the original value. So 2.58% error is there. Then last, what's that, least count error. Already familiar. What is least count? Least measurement of the instrument is called least count. So least count is the error associated with the resolution of the instrument. The least count errors of any instrument is equal to its resolution. The length of a pen is likely to be within 4.7 plus or minus 0.1 centimeter. Clear? So this is the way we can discuss the types of errors. So next video I will tell the what's that next concept, significant figures. And also in this topic, one more thing is there, combination of errors. I will tell you in the next class. Thank you.